Today we are talking about FRQ, the FRQ topic of data or table questions. Data and table questions. Given a table of data, usually a time and either a function or a rate function on a closed interval with an initial amount given, we must be able to do some of these things. Estimate a derivative. That's a frequently asked question, typically found in Part A. Estimate the derivative. Okay, to do that, we do change in the function in the table over change in time or whatever the independent variable is. Know how to determine units for that. Okay. Another thing that we're asked to do is use some kind of estimation technique using left-right Riemann sums, midpoint sum, trapezoidal sum, and all of those estimate the value of an integral. Okay, that's what they do. Okay, remember that the integral of a rate gives you a change in amount. The integral of a rate gives you a change in amount. Okay, that's the fundamental theorem of calculus. That's huge. You know, fundamental theorem of calculus is going to be seen over and over and over again. Also remember the average value of a function. The average value of a function. Okay. Another way to write, I'm not sure why I put this here and not just above it. Another way to write what I said in Part A, or in this part here, is written like this. The amount at time B is equal to your initial amount plus the change in the amount. Okay? The Riemann sum always only gives you the integral. It does not take into account anything else that is being done in your expression. Okay, other things are telling if an approximation is an over or an underestimate, using the candidates test to find an absolute min or max, explain the meaning of things. Okay, we are going to be using the acronym NUT. Noun, units, time. Where noun is usually it's usually / always more than just a single word. It is what the thing is. Okay, height of the tree, rate of change of the amount of water entering a tank, whatever it is. Okay, you will be asked to explain the meaning of a derivative, of an integral, of the absolute value of an integral, or the integral of an absolute value of a function, and this expression, which gives, as soon as you see that there's a fraction out front, that is the average value of the function. Okay, MVT, IVT, those are commonly seen here. Okay, and oftentimes be aware in Part C or D, oftentimes they will give you another function and ask you to do something sometimes very random and completely different on Part C or D. So just be aware of that. Be ready for anything. I always tell kids, just do whatever they tell you to do. All right, let's take a look at some examples. This first example was back in 2013. All right, we see the table. It says hot water is dripping through a coffee maker, filling a large cup with coffee. The amount of coffee in the cup is given by a differentiable function C. Since they have told me that C is differentiable, I know that they can ask me MVT or IVT questions about C. Okay, selected values of C measured in ounces are given in the table. Great. Okay, use the data in the table to approximate C prime of 3.5. C prime is the instant slope of C. An approximation for C prime will be the average slope. So we want it at 3.5. I go find where would 3.5 be in my independent variable. 3.5 would be right here. So I'm going to use 3 and 4 in my approximation. So the average rate of change there, C of 4 minus C of 3 over 4 minus 3. C of 4 is 12.8. C of 3 is 11.2. There is never any reason to simplify. I'm going to leave it right like that. I reread the question, make sure you got everything, use the data to approximate this, show the computations that lead to your answer, and indicate units of measure. We need to come back and indicate units of measure. To find units of measure, you take units of the top divided by units of the bottom. So units of the top are ounces. Units of the bottom are minutes. Ounces per minute. Okay. That year, let me see what, let me find my scoring guidelines for this one. That was worth 2 points. 1 point for the approximation, 1 point for the units. Part B. Is there a time between 2 and 4 at which C prime is 2? C prime. Our table has C in it, and they're asking me for C prime. The way this is worded, I know it's either IVT or MVT, and I know it must be MVT because they gave me C. They're asking me about C prime. So I know I'm going to have MVT here. For MVT, we need to, these were the ones where we had the 3 little dots. Okay. The last one will be our conclusion. These two can be switched. Doesn't matter which goes where. I like to start with my basic conditions for MVT. And that says that the function in the table, not this function, that function. The function in the table, C, is continuous on the closed interval that they gave me, 2 to 4, and differentiable on the open interval, 2 to 4. That's the minimum basic condition for MVT. Since C is given to be, and we say exactly what C was given to be. C was given to be differentiable. That's what we say. If C had been given to be twice differentiable, I would write twice differentiable here. Don't abbreviate, just write it out. So this is the minimum basic condition that must be satisfied for us to use MVT. Now here comes the meat step, the mathy part of it. And what that says is that I want the average rate of change of C to be 2. And the average rate of change of C is C of 4 minus C of 2 over 4 minus 2. From my table, C of 4 is 12.8. C of 2 is 8.8. That is 4 over 2, which is 2. That is exactly what they told me it must be. If I had gotten something else, I did something wrong. Or there was some inner interval where it would be true. Okay? So both of those must be written before you write your conclusion. You will not get credit for any conclusion without both of those. Okay? So then I can say so, or therefore. You can use the 3 little dots if you want to, or the arrow with the double bar on it. So, and now I go back and I say, I rephrase this, but I write it as a statement. I don't write it as a question, I write it as a statement. So, there is a time t. Between 2 and 4, I'm writing exactly what they say. At which c prime of t equals 2. This is always worth 2 points. 1 point for your meet step, your c of 4 minus c of 2 over 4 minus 2, showing that that is equal to 2. That's always worth 1 point. And then 1 point for what they always call the justification or explanation using MVT. We did use MVT. We didn't say we were using MVT, but we did use MVT. Okay, that 1 point is for all 3 of these steps. Okay, part C, use a midpoint sum. A midpoint sum with 3 subintervals of equal length indicated by the data in the table to approximate the value of this integral. And then, using correct units, explain the meaning of that integral. Well, as soon as I see the 1/6, I know the meaning of that integral. It's the average value of c. It's the average c. I already know the meaning, but I'm going to go and do what they said first. The midpoint sum. So for a midpoint sum, I'm coming to my table. For a midpoint sum, and we're going from 0 to 6. First of all, this 1/6 that's out in front will not be part of my midpoint sum. I have to add it myself. So 1/6. Big integral, my midpoint sum will go inside here. Okay? Don't forget your 1/6 though. So now for the midpoint sum. I'm starting at 0, I'm ending at 6. And I want 3 intervals of equal length. So I'm going to go from 0 to, and this is the way they always do it with a midpoint sum. You start where you start, skip 1, go to the next. And then start there, skip 1, go to the next. Then start there, skip 1, go to the next. That's how you get your 3 subintervals. So we are, for the first subinterval, we're going from 0 to 2. For a midpoint sum, you're using the middle function value. You use those two. So I'm going to write down 5.3, that's my function value, times change in t. You can write this as 2 minus 0 or just 2. So in general, this is our middle c value, and this is delta t. Okay, plus, and now we're going to go to the next one. For this one, I'm starting at 2, going to 4, and I'm going to use its middle function value, the 11.2. So 11.2 times 4 minus 2, or you can just write 2, plus. Last one, we're going to start at 4, end at 6, use its middle c value, 13.8 times 2. Okay, now for the explanation, the meaning. We're using our NUT acronym. Noun, units, time. I like to start with time. To me, it has a better flow. So, I need to explain the time. The times are from 0 to 6. So, from 0 to 6 minutes. You have to write your units on your time as well. From 0 to 6 minutes. Okay. Now I want the meaning of that integral. So, the meaning of the integral, I know it's average. Average what? It's average c, but I cannot put the average c because that's not the context of the problem. I need to know what c is. It's the average c, where c is the amount of coffee in the cup. So the average amount of coffee in the cup is 1/6 integral 0 to 6 c of t dt, and then I need units. Okay, what would units be for the average amount of coffee? That's just ounces. That is just ounces. Okay, so for the sake of your notes, the average, that was because of the 1/6 out in front. Amount of coffee in the cup is C. So average C. And then for the units, if you for some reason can't figure out the average amount would be in ounces, you can always do a unit analysis over here. C is in ounces. Delta T is in minutes, because that's a time. 1/6, that came from 1/minutes. If you multiply all these together, you get ounces. You can always do a unit analysis on your integral or derivative to get your units of your final answer. Okay, part D. The amount of coffee in the cup in ounces is now modeled by this function B. So they like to do this, you guys. In the table, they said that C was the amount of coffee in the cup. But now they're saying that B is the amount of coffee in the cup. They like to do this. Okay? Using this model, find the rate at which the amount of coffee in the cup is changing when t equals 5. This is a no calculator problem. It's on the no calculator part of the test. They're asking us for the rate that the amount is changing when time is 5. So if they gave me the amount and they want the rate, that's B prime. So B of t is given to us to be this. We're asked to find B prime at 5, but first I'm going to find B prime of t, and then I will plug in 5 for t, since I have no calculator. If I had a calculator, I could just plug this into my calculator. The derivative of this at time 5, I would just call it B prime of 5 is equal to, and I would get my answer. But with no calculator, we're doing this by hand. Okay, the derivative of 16 is 0. The derivative of this piece will be, so the derivative of e to the power is the derivative of the power times e to that same power. So that negative 16 that's out there needs to be multiplied by the derivative of negative 0.4t, which is negative 0.4. And then it's going to be e to the negative 0.4t, just as we see it there. And you know what? This is an FRQ. We can just leave it like that and plug in 5 for t. And just completely leave it like that. We do not have to multiply those decimals together. College Board is not trying to see if we can multiply decimals together. So this, that's one of the things that are good about FRQs, is that you don't have to simplify things like that. Okay, I forgot to give you the point breakdown on part C. Let me go back and do that. On part C, this was worth 3 points. 1 point for just the midpoint sum. That's what I have in my brackets there. 1 point for your entire approximation. That would be including the 1/6. And then 1 point for your interpretation. For part D, they gave 1 point for B prime of t and 1 point for B prime of 5. So 2 points. Okie doke. Next up, we are going to the question from 2017. 2017. So I will go get those guidelines. All right. 2017. A tank has a height of 10 feet. The area of the horizontal cross-section of the tank at h feet is given by function A, where A is measured in square feet. Function A is continuous and decreases as h increases. So we have this tank. It has a height of 10 feet, and the cross-section areas decrease as h increases. So I don't know what this tank looks like, but it's not a cylinder. I don't know what it is, but the height is decreasing as the height increases. So the height is 10 feet, like that. I don't know why I drew it slanted. The height is 10 feet. That should be perpendicular. Okay. Alright, so our tank is looking something like that. Alright, part A, use a left Riemann sum with 3 subintervals to approximate the volume of the tank. Well, the volume of the tank is the integral of the area of the tank, and the area of the tank is A of h. We are going from 0 to 10. I don't have to write that integral here, but that is why I'm going to be using a left Riemann sum to approximate the volume. Volume is always the integral of the area cross-section. Okay, left Riemann sum, 3 subintervals. I go to my first delta t. My first delta t is 0 to 2. I'm using the left, for a left Riemann sum, we use the left a value, and then we multiply by delta h. So left a value would be the 50.3 times change in height would be 2 plus. Next interval. Its left function value is 14.4. The delta t is 3. Next one. Its left function value is 6.5. Delta t is 5. There's my left Riemann sum. That approximated the volume in the tank. Now all I have to do is indicate units of measure. What would units of measure be for a volume of this tank? H is in feet. Volume will be in cubic feet. Okay, this was scored. The way this was scored, 1 point for the left Riemann sum, 1 point for the approximation. So if you can't stand it and have to simplify, it has to be correct. But as I wrote it, this expression satisfied both the left Riemann sum and my approximation. So this part alone was worth 2 points. They also had a separate point given for the units in part A, part C, and part D. So even though we haven't gotten there yet, 1 point was for 3 different units. So far, so good. Okay, part B. Does the approximation in part A overestimate or underestimate the volume of the tank? Well, A, the function A, we know is decreasing. A is decreasing. We used a left Riemann sum. So I'm going to draw a rectangle underneath that decreasing function. And the rectangle is going to be touching the curve with its left side. Its left side will be touching, so when I'm going to draw a rectangle, and its left side will be touching that curve. Do you see how its left side is touching the curve? Okay, I'm saying that because I've had kids in the past have difficulty with this. Its left side is touching the curve. That's a left Riemann sum. The rectangle is over the curve, so this is an overestimate. So to say that, we be brief. We don't elaborate at all. We say overestimate, give them the answer, since we used a left Riemann sum and A is decreasing. Okay, or you can say we use a left Riemann sum on a decreasing function. Okay, that was worth 1 point for overestimate with reason, they said. I have made several videos today already, and I can tell when my writing gets really messy that it's time to stop the videos for the day. Okay. I also have been out in the garden, so my fingers are gross. So I apologize for my dirty hands. Okay, part C. The area in square feet of the horizontal cross-section at height h is modeled by function f. Okay, so that was the area was A in our table. Now they're giving a function for that. So again, I see this all the time with AP. They give you something here, and then they give you an equation for the same thing. Okay? Based on this model, find the volume of the tank. We approximated the volume of the tank up here using A. Now we want to find the volume of the tank down here. And by the way, this was with a calculator. So we have a calculator access to access this one. So volume is integral of area. There's area. So the integral of f of h, I don't need to write out the actual equation, just call it what it is, f of h. The integral from, okay, what values of h should we use if we want the volume of the tank? Well, we want to start at the bottom and go to the top, which is 10. So in my calculator, I'm going to put in for y1 50.3 divided by parentheses e to the 0.2h plus h, close my parentheses. I'm looking at the equation to make sure it's correct, and it looks correct to me. Okay, then I'm going to go to my home screen, and we're going to do math 9, 0 to 10 of h. That's my y1. And we get that the volume of the tank is 101.325. Remember to give at least 3 places after that decimal point. 3 numbers after the decimal point, at least. If you want to give more, give more. They just won't be graded. You will be graded on the first 3 though. So if any of these are wrong, it's wrong. You don't get credit for it. This was worth 2 points. 1 point for the integral, 1 point for the answer, and I just realized that as I was writing that, I didn't write my units of measure, so I need to write my units of measure. This is still the volume of the tank. This is still feet cubed. Okay. I think the last thing to do in every problem is go back and look to see if you missed any indicate units of measure. Okay, down here, I'm hoping that I remember to indicate units of measure. Alrighty, part D. Water is now being pumped into the tank. Okay, when the height of the water is 5 feet, the height is increasing at a rate of 0.26 feet per minute. dH dt, they are giving me dH dt when the height is 5 feet is increasing, so it's positive 0.26 feet per minute. If they said it was decreasing, I would have to write that as a negative. Using the model from Part C, find the rate at which the volume is changing with respect to time. So find dV dt when the height is 5 feet. And indicate units of measure. Alrighty, so volume. The volume is, I need to write an equation for the volume. The volume of the amount of water that is, as it's being put in, it's not the volume of the tank. We already found the volume of the tank. We want the volume of the amount of water. So that is going to be the integral of this tank as it's being filled, right? The integrand will be f of h. My question is, what do we put for the boundaries? And in class, I would spend a couple minutes talking about these boundaries. Most kids say we need to start at 0, and I said, I absolutely agree with you. We do need to start with 0. Where do we need to end? We're not going all the way up to 10. And many kids will say, let's stop at 5. We should go to 5. But that's not right either, because we have a changing situation here. Water is in the process of being pumped into the tank. When we find the derivative of something, we don't plug in the final answer until we get to after we take the derivative. We want this to be flexible. And at that point, usually kids in class will say, we need to end that at h, because it's changing. H is changing in the problem. And I said, absolutely. We definitely do need to end it at h. So now we're going to take the derivative of both sides of this messy thing with respect to t. Why? Because they told me to. So we get dV dt is equal to, all right, we're taking the derivative of an integral. So that triggers in my mind the second part of the fundamental theorem of calculus. And at this point, when I'm in class, I would go off to the side and we would refresh on the second fundamental theorem of calculus. So that's what I'm going to do right here with you guys. I'm going to go off to the side and we're going to refresh on the second part of the fundamental theorem of calculus, which says if we have a function, I'm going to call it g, and g of x is defined as an integral, like v was defined as this integral here. If g is defined as an integral, and I don't care what function it is, I'm going to call it f of t, dt. Okay? And we have boundaries. We have boundaries. Since g is a function of x, you're going to have x's here. But it can be anything with x's. I'm going to call it a to b, where a and b have x's in them. Okay? And now I want g prime. We want the derivative. How do you take the derivative of an integral? Well, the derivative of this integral will be, you start up at the top and you take its derivative. Remember that it has x's in it. So you take its derivative, b prime, whatever that is, and then you multiply by, put b in for t, or whatever letter is there. That was completely random. It could be any letter, even x's, okay? Doesn't matter. Minus, now go to your bottom boundary, take its derivative, and then put it in for t, times f of a. That is the second part of the fundamental theorem. Okay? So let's go back to this one. We start at the top, take its derivative with respect to whatever they tell me to take the derivative of with respect to. So dh dt times, put h in for h, so f of h, minus, take the derivative of the bottom. The derivative of 0 is 0, times f of 0. That's just 0. Yeah? So when h is 5, dv dt will be dh dt is 0.26 times f of h, f of 5. So back to my calculator, f of 5, a little blurry there, will be y1 at 5. Don't forget your calculators have a function that will evaluate the value of a function. So 6.516. Because this is not our final answer, I'm just going to write a bunch of decimal places here. And then I could just stop right there. But if you want to go ahead and multiply that by 0.26 and get 1.694, now you can round. Now you can round it to 3 places. Do not round until the very end though. So if you're not to the very end, write more places than you need. I'm curious if I had just used 0.26 times 516, would that have given me the right answer? And it would have. This time, it would have given me the right answer. But sometimes it won't. Sometimes you'll have a little error there if you round too early. This was worth 3 points. 1 point was for, 2 points were for dv dt. That implicit to this step right here. 2 points. And then 1 point for your answer. 3 points. Okay? So guys, that's what we did on one day in class. And then the second day on this topic, I did one more FRQ. So I thought I would go ahead and do this last FRQ that I did on day 2 in class. This was the one from 2022. So I thought I'd go ahead and do this with you too. Alrighty. An ice sculpture melts in such a way that it can be modeled as a cone that maintains its conical shape as it decreases in size. It's a magical cone that always remains a cone as it melts. Okay? The radius of the base of the cone is given by a twice differentiable function r, where r is measured in centimeters and t is measured in days. The table gives selected values of r prime, the rate of change of the radius over the time interval 0 to 12. Okay? So, the rate of change, it was melting fast, and then as time goes on, it melts a little bit slower, right? That's what it appears to be doing. Okie doke. Let's see what they have us do here. Approximate r double prime of 8.5. Well, if they gave me r prime in the table and they want me to approximate its slope at 8.5, I will use change in the average rate of change. So I go to 8.5. Where would 8.5 be? 8.5 would be between 7 and 10. So I'm going to use 7 and 10. Don't use anything else or you will not get credit for this. Did I give units in that last problem? I did not give units, you guys. Seeing indicate units of measure made me realize I did not give units in my last part of that last problem. Oh, I swear, I forget it all the time. Okay, what would the units be here, you guys? Units there. Sorry about that. Units of V divided by units of t. So, feet cubed per minute. Units of v, units of t. Alrighty. I'm kind of happy that I remembered that, even though it was late. Oh, okay. Alright, so I need to remember units. Units. Alrighty. So I'm using 10 and 7 here. So I will have r prime at 10 minus r prime at 7 divided by 10 minus 7. And that is negative 3.8 minus a negative 4.4 over 10 minus 7. Okay, all is good. Let's give them some units. We need units of r prime divided by units of time. I'm sorry, this isn't time. Oh yeah, it is time. Never mind. Units of r prime divided by units of time. So r prime is in centimeters per day. So we could write this as centimeters per day divided by day or days. That's fine. There's nothing wrong with that. Or you could say centimeters per day if you wanted to. Or you could say centimeters per day squared if you want to. All of those are the same thing. They would all be given full credit. Okay? This was worth 2 points. 1 point for your approximation. 1 point for your units. 2 points. Is there a time? Is there a time from 0 to 3 for which r prime is negative 6? All right. Our table has r prime in it, and they're asking us, must r prime be negative 6? Well, I go to my table, r prime. Where would r prime be negative 6? Where would negative 6 fall? Well, it would fall between 0 and 3, true? And that's exactly where they told me it would be, so that was nice of them. But yes, negative 6 has to be between here because they told me that r is twice differentiable. So I know that r prime must be continuous. The table has r prime. They asked me about r prime. So this is just IVT. This is just IVT, not MVT, IVT. So we still have the 3 little parts. The last part is conclusion. The second 2 or the first 2 can be swapped. I like to do my basic condition here. For IVT, there's only one thing that must be happening, and that is the function in the table must be continuous on the closed interval. So r prime is continuous on the closed interval 0 to 3 since, why exactly? Since r was given to be twice differentiable. You say exactly what they told you. R is given to be twice differentiable. Okay? Now for the meaty step. The meaty step, pretty much I just need to say that negative 6 is between these two numbers. But I need to say it right. So I'm going to say r prime at 0 is negative 6.1. R prime at 3 is negative 5.0. Negative 6 is between these two numbers or values. That's all you have to say. Okay? Therefore, or so, there is a time between 0 and 3 for which r prime of t is -6. 2 points. 1 point for, here's how they wrote this, 1 point for saying that r prime of 0 is less than -6, which is less than r prime of 3. That's exactly what we said when we said our meet step. You always get 1 point for your meet step here, you guys. And then 1 point for your conclusion using IVT. You do not need to say you're using IVT, but you need to do all the work for IVT. Okay, part C. Use a right Riemann sum with 4 subintervals indicated by the table to approximate the value of this integral. Okay, right Riemann sum, so I'm going to be using the right r prime value, and each time I'm going to multiply by change in t. And I'm going from 0 to 12. So 0, 0 to 12 here. So my first subinterval is 0 to 3. I'm using the right function value. So I'm using the -5.0. So -5.0 times change in time, 3, plus next interval. The right function value is -4.4 times change in time, 4, plus the next interval, 7 to 10. The right function value is -3.8 times change in time is 3, plus the last one, the right function value is -3.5, change in time is 2. Did we need units? We did not need units for that one, so we're just done. They gave 1 point for what they called the form of a right Riemann sum, and 1 point for the answer. 2. Okay, last part, part D. The height of the cone decreases at a rate, so the height of the cone decreases at a rate of 2 centimeters per day. So they are telling me that dH dt is equal to a -2, the height of the cone. Okay? At time 3 days, the radius is 100 centimeters and the height is 50 centimeters. Find the rate of change of the volume of the cone with respect to time. So we are finding dV dt at time 3 days. And they give us the formula for the volume of a cone. So the volume of the cone is, I'm leaving a space because I'm going to be taking the derivative, 1/3 pi r squared h. And we're looking for dV dt, so we come in, we take the derivative, dV dt. Alrighty? Okay, so dV dt will be, over here I'm taking the derivative with respect to t, and I have an r and an h. I'm going to use the product rule. I'm going to use the product rule, and I'm going to have called one piece the first 3 things here, and the other piece the h. So the derivative of 1/3 pi r squared is going to be 2 times the front, so 2/3 pi r dr dt, because r is not t, little implicit differentiation there, multiplied by the h left alone, we're doing the product rule, plus Now I'm going to leave the first thing alone and multiply by the derivative of h dh dt. Okay, when t equals 3, when time is 3, dv dt will be 2/3 pi times r. What was r then? R is 100. What is dr dt at time 3? Did they tell us dr dt? They did tell us dr dt in the table, because is this not dr dt? It is dr dt. So at time 3, dr dt is -5. So -5 times h, which is 50, plus 1/3 pi r squared times dh dt, which they gave us as -2. All numbers. I'm done. I am looking to see if I have to indicate units of measure, and I don't. So we're done with that one. 1 point for the product rule. 1 point for the chain rule. That's what they called it. That's your implicit differentiation. That is having the dr dt and the dh dt. And then 1 point for your answer. Okay, done. A little bit longer video because I did 2 days worth on this one.